Hey students, how you doing? Today we're going to graph some logarithm functions. Let's go ahead and get in that. In class, either today or yesterday, depending on when you're watching this video, we learned about the parent function for a log graph and where it comes from. It's the inverse of the exponential function y equals b to the x. And we have this vertical asymptote along x equals 0. It will have this general shape if you're using graph paper. And the three key points that I'd like for you to always consider would be the point 1, 0, the point b1, and the point 1 over b comma negative 1. And that's our parent function. Now, one thing that's nice about logs in graphing them, I'm not really sure why, but math teachers have decided that we don't have to do any kind of dilations on logs. So we have to worry about x-axis reflections, y-axis reflections, vertical translations, and horizontal translations, and that's it. Nice. So, start off with number 1 here. Negative log base 4 of x minus 3. So log base 4, so I personally like to consider the parent function. The parent function will look like this with x equals 0, and instead of a base of b, like this example had, it's a base of 4. So this point right here will be 1, 0. This point here would be 4, 1. And then this point here would be 1/4 negative 1. Inverse of these are the inverse points of the exponential function y equals 4 to the x. All right, looking at this. Negative out front. Negative out front always means that x-axis reflection. This x minus 3, it's inside the function. So it's going to affect the x coordinates, and because it says x minus 3, that means that it's going to be going right 3. I always like to do the xy thing, and if it's going right 3, it's going to be x plus 3. If it's going to be an x-axis reflection, it means it's going to be negative y. Hey students, this is really important. On that last test, a lot of people had correct graphs, but they forgot to show any work. So I could only give it like a 2 or a 3 depending on how good that graph looked. Make sure you show your work when graphing. You must either list the transformations, or you must mathematically tell me what you're going to be doing to those specific points. A lot of people weren't doing either of these. They're just graphing it. And then also specifically, the fractional point needs to be identified exactly what that coordinate is, because it's not always going to fit on a perfect happy spot on your graph paper. All right, so these three coordinates, 4, 1, 1, 0, 1/4 negative 1. I'm going to add 3 to the x coordinates, so it's going to become 7, 4, and 3 and 1/4. But Elliot hates mixed numbers, so 12 plus 1 is 13, so 13/4. So 13/4. The y is just going to change from positive to negative, so negative 1, 0 stays 0, and positive 1. Okay, now how's this going to look? If it's moving right through, it's still going to be a vertical asymptote, but because it's moving right 3, this asymptote, instead of being at x equals 0, is going to be at x equals 3. An x-axis reflection, that's the vertical type reflection, and if you take this graph and reflect it over the x-axis, instead of going down the asymptote, it's going to be going up the asymptote and then heading off like that. It's kind of look a little bit like a decay, but not really. And then anyway, the point closest to the asymptote's that fractional one. So 13/4, comma 1, 4, 0. and 7, -1. And I strongly urge people after this last chapter, unless you are extremely good at the visualness of what's happening with graphs, you should use graph paper. Because when you're using graph paper, you at least let the grids kind of do some of the thinking for you. I've had a lot of people, like on the last test, they gave me a graph that looked like this, but then it used these exact coordinates. So they had the coordinates right, but the place that they put the coordinates showed that they weren't really understanding what was going on with those transformations. They're just thinking about the coordinates, not thinking about the graph. That's the downside with not using graph paper, I guess. All right, one more example of a graph. Let's do log base 6 of -x plus 2. So log base 6, let's think. That's x equals 0, has this look. Those 3 key points are 1, 0, b 6. No, wait, that's not right. It's b. Is it b1? You can always use your parent function for a guide if you're having trouble remembering. B is 1. We'll talk about why b is 1 at a future date, but b should actually be a 1. Ugh, Elliot's screwing up. So the base is the b. So it's not b, it's 6. And when you plug 6 into the formula, out it's supposed to pop 1. And if you think about the other one, 1/6. 1 over b would have a value of -1. Alright, got to get that parent function locked down. It's been a while since I've graphed these. It's been a year, basically, so even I have to remind myself, what's that parent function look like? Alright, -x, it's on the inside. That is a y-axis reflection. The +2, it's on the outside, so it's going to affect the y-coordinate. That graph's going to go up 2. Or if you think about the xy thing, a y-axis reflection is going to affect the x-coordinates, so -x. Up 2, that's going to affect the y-coordinates, so y plus 2. We're going to perform this to our 3 key points, 6, 1, 1, 0, and 1, 6, -1. X-coordinates are just going to go from positive to negative or negative to positive, so -6, -1, and -1/6. Y plus 2, 1 plus 2 is 3, 2, and -1 plus 2 is of course 1. Alright, now I always like to draw on my asymptote first. It's not going left or right, so it's still at x equals 0. Let me zoom out so we can see the entire graph, see everything going on. The look, what's that graph look like? If it has a y-axis reflection, it would reflect this way. Ellie dropped his pen. So if it's going to reflect horizontally, instead of pointing to the right, it's going to point to the left, but it would still hug the asymptote down here at the bottom. So it'll have this look, and then the point closest to the asymptote is -1/6, 1. That middle point is -1, 2, and our third point is -6, 3. And that's graphing logs. I guess the last thing I could think of, just do a really quick example 3. What if it was y equals -log base 3 of -x? So you have both an x and a y reflection. And if we think about this, it'd still be x equals 0. We'd still have the point 1, 0, the point 3, 1, and the point -1/3, or excuse me, +1/3, -1. And then because this one's a negative out front and a negative inside, this is a reflection over both the x and the y-axis. if I'm reflecting over the x and the y-axis, that's actually not going to change the asymptote. The asymptote would still be at x equals 0. But if I reflect over one axis, it would be pointing this way. If I then reflected it over the x-axis, so it would then, think about this bit by bit. So if I did my first reflection, it would look like this. My y-axis reflection would look like this. So then when I do an x-axis reflection, it would then look like this. So it would look like this. And challenge for you, what would those three coordinates be? So, all right, that's part one. Part two is the opposite type of problems. Writing equations of logarithmic graphs. So how do we go about writing those equations? And like I said before, we do not need to worry about dilations. One thing I'm curious about looking at these problems is are they going to give us the base on are they going to give us the base? So give me 1 second, everybody. I need to look this up. I'm pretty sure in these problems they are going to give us the base. Oh, I have that right here. Yeah, they are going to give us the base. Okay. So knowing that they're going to give us the base, let me just do a little bit of work here. This second one, this one's going to be a base 2. And then this one, if it's going from 4 to 13, this one's going to be a base 10. Okay. So let's get into this. They're going to tell us this one's a base 10. So knowing that it's a base 10, you might want to think, well, what happens with a typical base 10? Well, a typical base 10 still has that key point at 1, 0, and that other key point at 10, 1. So I would handle this the exact same way that we handled the last unit, except I guess I'd go in this order. That the first thing I looked for on the in the exponential is I used the asymptote to give me the vertical translation. So in this case, the asymptote will give me the horizontal translation. If you recall from the second thing was to figure out in an exponential graph if it was going left or right, and you used the 0, 1 point. So in this case, we will use the 1, 0 point, specifically looking at the 0, and that'll tell us vertical translation. Third thing, based off the look of the graph, the look will let you know about reflections. And then fourth thing you would look for is dilations. And I've already told you we do not need to worry about dilations. So we're just going to write, not this year. All right. So we really only have to worry about horizontal translation, vertical translation, and then the look is going to tell us about the reflection. All right. So on this graph, it appears that this vertical asymptote is at x equals 3. So I know for right off the bat, this is one's going right 3. Then second thing, this point right here, the one that's right on this nice happy point, that's our 1, 0 point. And I notice it's all the way down here at -5. So that means that this graph is going down 5. Then, after that, this graph actually has the right look, so there's no reflections. So I just need to use a base 10 graph, so it's log base 10. Right 3 would be x minus 3. Down 5, I could either put a -5 plus in front. I usually like to put my -5 out back. And then that would be your equation for this one. That's it. I want to say something profound, but I can't remember that profound thing I want to say. So let's just do one more example. This one's a base 2, and a friendly reminder, a base 2, typically at x equals 0, and then a key point at 1, 0, 1, 0, which would mean the second key point's at 2, 1. Now, when you look at the graph, if they give you 3 points, ignore the fraction point. Now, asymptote will tell if it's going left or right. Asymptote's at x equals 3, so it's going right 3. 2, the 0, or excuse me, the 0, I'm used to saying the 0, 1 point. The 1, 0 point will let you know if it's going left or right, or excuse me, up or down. Ugh, get this backwards. Start over. The 1, 0 point tells you if this graph is going up or down, and we look at that y coordinate. Because this has a y coordinate of 1, this coordinate is 4, 1 here, I know that this graph has gone up 1. Third thing, reflections. I'm used to this having this look, but this graph has that look. So that has been an x-axis reflection. And now we put that into our equation. It's base 2, so log base 2. X-axis reflection, that affects the y, so the negative is out front. Right 3 would be x minus 3, and then up 1 on the outside would be a plus 1. So this is a nice, good problem. It had 3 different transformations. And that's it. That is it for both graphing logs and writing equations for logs. I'm really glad we don't have to deal with dilations. That's going to make this chapter a little bit easier, a little bit nicer. Anyway, I hope you've enjoyed this lesson, and I hope you have a great rest of your Wednesday evening or Thursday, if that's when you're watching this. And I'll have a great day. If you have a great day, talk to you later. Bye-bye.